Hello and welcome to my second presentation. This time it's for visual cognition. As you can see, there is no complex editing this time because there is just too many pictures. I don't love how this presentation looks like because I don't love my camera and the quality of the sound that my computer records, but here I am. I hope it is still nice. So as you can see, this presentation would be on segmentation of object outlines into parts. And to begin it, I would like to do a little exercise and ask you to mentally divide these two objects that I'm going to show you into parts. So let's start with the first one. So here is the first one. Just take a moment to think how you would divide it into individual segments. And here is how you probably more or less divided it. So we have a division into individual limbs, then into feet. Maybe you divided hands from the rest of the arms. Maybe you divided fingers from hands. And that was quite easy, I reckon, because you have outlines, exact contours that help you do the division. But now let's take a look at the second picture. So here, maybe it is more tricky, but take a few seconds to think how you would divide this one into segments. And again, I reckon this is most likely how you more or less divided it. And it makes perfect sense. We have limbs, we have ears, we have trunk, maybe we have tasks divided. And yeah, it makes a lot of sense. But now, how did you do it? Because you don't have any contours here, you don't have any lines you can follow while doing the division. And you might answer that, okay, here we can perfectly well see where the belly ends and the limbs start. Okay, but then with ears, how do you know? How do you know this is a separate part, really? Yeah, and again, you might say that there are some obvious dividing lines, but are there really? Would it be here? Or maybe here? Well, if we zoom this in, you can clearly see that this is not so obvious where the face or the head ends and the ear begins. But then you saw it. You probably saw it clearly that here we have a head and here we have an ear. So why is that? Well, this is because your mind wants you to see things divided into parts. So your mind told you that here you have one part and here you have another part. Alright, so we've established that our mind wants us to see segments and boundaries. But why is that? Well, imagine you are eating a chicken with your family and you have no way whatsoever to divide it into any meaningful parts and no way of naming these parts. How would you describe which piece of the chicken you want to eat? Well, it is perfectly reasonable for us to have names and concepts of individual segments of the chicken. So yeah, it is quite natural and it is quite useful, both for our visual cognition to have this idea of segments and for things such as language, ergo communication. And it probably made some perfect sense from evolutionary perspective too. So we are able to perceive whole objects based on just seeing their parts. And it probably was quite important for us to be able to see a partially occluded tiger and perceive it as a whole dangerous tiger. So to sum this introduction up, segmentation is useful for us because you can easily identify objects based on their parts, you can communicate more precisely, your cognition too is more precise because you have this idea of objects having individual parts, and you can easily distinguish between figure and ground and between different figures. But how do we segment objects? Is there any set of rules that allow all the humans more or less to agree on how to divide individual objects into separate segments? Well, a lot of researchers have tried to answer these questions. And maybe they have not failed, but none of them really managed to answer the question fully. That is why De Winter and Wagemans have decided to conduct a large-scale integrative study. They combined a bunch of different theories to see if they are empirically applicable. They have gathered 201 subjects, which, by the way, were their students. They've created a set of 88 stimuli, which were 88 outline shapes derived from 260 line drawings of everyday objects. They have introduced two conditions. So some of these objects were quite easy to recognize, and the other were quite difficult to recognize. The procedure in the study was as follows. So first, the students had to name the object, and then they had to try and segment it. So they have the stimuli provided on a piece of paper, and using pen, they just needed to draw lines dividing the objects into individual segments. This is more or less how the task looked like. So first, you would be required to name the stimulus. So here we have a swan, and then your task would be to divide it into parts. So there are no good and wrong answers. This is about how you feel the stimulus should be divided into parts. So for me, for instance, a segmentation should be here, here, perhaps here. Maybe I would add some segments here. And yeah, that would be my answer. I hope it is quite understandable. So having conducted the study, they have put the answers into computer, and this is how the results looked like. So here you can see the lines showing you how different people have divided the objects, and these blue and red lines show you the most common or like the mean places of where the objects have been divided. And the main findings that they had were first that there were really strong tendencies in the majority of pictures. So in really most of them, you could see at least a few of these blue lines, meaning that the majority of people had more or less a similar idea on how to divide the objects. These tendencies were even stronger in easy to recognize pictures than in the ones that were harder to recognize, so harder to name. And then they have distinguished, based on the theories that they've introduced earlier, but also on the findings, 5 major factors of segmentation. So the first factor is that of negative curvature, or negative minima. So negative curvature is when in a 3D object, the curves are sort of bended inwards, like into the object. So they are not curvy, they are not pointy, but rather they point inside. And that is where in a 2D representation of this 3D object, there would be segments perceived. And yeah, that would make segments perceived here in this case. And that is actually what empirical findings have suggested. So this would be the first factor. The second factor would be that of good continuation. So if you divide an object into 2 parts, the parts kind of make sense geometrically. So if you, for instance, divided this object here in the middle, then it would kind of be awkward because suddenly you have this pointy curve and the segments are sort of unfinished. So this would not be a good continuation, and this would not be a very likely place for segmentation. But here or here, if you remove the ears or tail, the rest is still nicely curved. So that would be a good continuation. The next factor is that of short distance between points. So the shorter the distance, the more likely it is that people would perceive the division in this exact place. So here, the short distances would be, for instance, here, here, here between individual feathers. So this is where it would be segmented, and this is where it actually was segmented. Also, dividing the object somewhere here would be a much better choice according to this rule than dividing it, for instance, here. So that would be the rule of short distance between points. The next factor is that of crossing symmetry and main orientation axis. So if you draw orientation axis here, it would probably be something like that. And the researchers have noticed that usually when there is such an obvious symmetry axis, it is segmented in the opposite way. So segmentation would be here, or maybe here, but rather very rarely here. So crossing symmetry is very common in segmentation. And the last very interesting factor is that of cognitive influences. So the idea is that our knowledge of the object influences the way we would perceive its segments. So in case of a horse, the knowledge we have about them having heads, tails, ears, limbs, and so on, having like functional parts, influences how we would divide the outlines. Similarly for instance, a key. It doesn't really make so much sense to create a division here and here. And maybe it would make more sense to create a division here, but this last division would be unlikely because we know that we have this part for having your keychain, the part for holding the key, and then the part for opening the doors. And this is how we would most likely divide the key into component parts. So our knowledge, our cognitive factors influence how we segment objects. Now, having found some proofs for all of these factors listed, the Winter and Wagemans have created a coherent framework that tried to explain how complex this segmentation is and what influences this process. So here we have cognitive influences and visual influences coming together to explain how they kind of interact to allow for segmenting the objects the way we do. So that would be all for the Winter and Wagemans. This is what they eventually came up with. But there's one more factor that I would like to focus on a little more. I would like to introduce you to some aspects of social semiotic approach. This approach is normally employed in contexts such as discourse analysis, social analysis, multimodal text analysis, so rather these more linguistic aspects of cognitive science. And it is represented by figures such as Van Leeuwen, Van Dijk, Halliday, O'Toole, so researchers typically associated with language. But it can be interestingly employed here as well. So cognitive linguists had this idea that an image should be seen as a communicative product constructed with an ideal model, and that actually cultural context is crucial for any meaning making. This top-down approach can also be employed in segmentation. So they would argue that when we see an image, a picture, or any scene, we segment it down into parts based on our cultural knowledge and basically our knowledge of the world. O'Toole have distinguished 4 categories of these divisions: member, figure, episode, and work. So figure is what we recognize as a whole in an image. Episode is a grouping of figures involved in shared processes of different kinds. Member is element of the figure that plays important roles in the overall meaning. And then work is overall level of the entire piece. And when we perceive things visually, O'Toole argues that we combine these 4 categories and perceive them and kind of go in and out between these different categories to segment what we see into some meaningful wholes. And just to briefly give you an example of how this might work, there was a preliminary study by Beres and Holshinova who kind of juxtaposed the semiotic approach method with a traditional eye-tracking method of tracing how people segment images. And what was interesting is that the preliminary results showed that this is quite similar. So when the participants were presented with this picture, what the eye tracker has shown very nicely tied in with what the participants have been saying in the context of how they divide the picture. So what they have been saying about the participants, the three men or the four men, the tree, the bed, and so on. So the way they perceived separate constituents of this image tied in with what the eye tracker could see. And now, to give you a summary of this short presentation, I would like to underline once again that segmentation is a complex cognitive task involving different factors and different categories. It is a useful and important phenomenon in human perception. Most likely, it is both a top-down and bottom-up process. So both our knowledge of the world influences how we divide the objects, but also how we divide the objects probably influences how we perceive them. Various factors influence how we segment objects and the entire scenes, as was already described. Segmentation is an early process in visual cognition that is also interesting, and thus it might in itself influence perception. And the last thing would be that more research is probably required to study various aspects of segmentation, because we could see that there really are a lot of factors that have not really been studied enough. So things such as social, spatial factors, maybe there could be some more research on computer vision and how computers can learn to segment scene the way people do. So there is a lot of room for other research. And that would be all for me. I hope it was clear. I hope it was interesting. Here are my sources that I have used to prepare this presentation. And thank you so much for your attention, and once again thank you for preparing this wonderful course. I have learned a lot. I have also learned a lot of interesting stuff while preparing for this presentation, so thank you for giving me this opportunity, and yeah, goodbye.